First dilemma, should I say hi or hello? Hi, my name is Gilbert-Snyder, and I'll be talking about the Magnus Effect. First, some background. I first stumbled upon this effect when I was doing my experimental physics project 2 years ago. My project was just to compare the trajectories of marbles rolling through air and water with the ideal trajectories. Like this. Seems simple, right? You'd expect the marble to not go as far in water as in air, and not go as far in air as ideally predicted, because of friction, but otherwise to have approximately the same shape of their trajectory. And that was what happened, for air. In water, though, let me just show you what happened. Oh, this water's cold! I think it's probably safe to say that very few people were expecting that. In fact, the first time I did that, I didn't believe my eyes. And I had to do it several more times before I even started taking pictures for my experiment. It took me longer than I'd like to admit to find out why that was happening. For some reason, Googling marble moving underwater didn't come up with any results. But I finally hit gold when my physics teacher suggested that there was the same concept as a curveball. And so I found out about the Magnus Effect. The Magnus Effect applies to spinning objects moving through some sort of viscous fluid and follows from Bernoulli's principle. Bernoulli's principle is that the faster a fluid is moving, the less pressure it exerts. Now, if you have a marble that's spinning as it moves through a liquid, so it's moving this way, then the liquid would be going this direction with relation to the marble. And so the marble's moving this way, and over here, since the marble is spinning in this direction, it will slow this water down because of friction. Over here, it'll speed the water up, and so there's going to be slower moving water over here and faster moving water over here, and so this will be a higher pressure zone, and down here will be a lower pressure zone. And so when the marble's moving in this direction and spinning, the force pushes it that direction. And so that's why when it comes down the ramp spinning, it curves in that direction. This is the Magnus Effect, and this is why curveballs curve. The really cool thing about my demonstration is that unlike curveballs moving through the air at 75 miles per hour, this is really easy to see with your bare eye, and it's really easy to demonstrate yourself. In science, even when you think that you know everything about something, like you think you know what happens when you roll a marble off of a ramp into water, there's always going to be new things that you don't know that you can learn.